thank you everyone for coming to my presentation. I'll be discussing the wildlife activity and connectivity on Highway 32. It's not working.
Just do the arrows, I guess.
Okay, so roads play a critical role in our societies. Without it, we won't be able to access resources, see our friends, and it facilitates our movement. However, with 4.2 million miles of roads across the U.S., it has significant ecological consequences. Roads result in habitat loss, fragmentation, degradation, and which results in overall loss of biodiversity. Also, it results in a direct loss of wildlife through wildlife vehicle collisions. More on the impacts of roads. So roads fragment habitat, disrupt wildlife movement, and increase the risk of wildlife vehicle collisions. These collisions are a major source of mortality of wildlife. Over 2.1 million road kills or collisions were reported in the U.S. between 2020 and 2021. Species such as mountain lions, deer, and black bears are particularly vulnerable due to their large ranges and mobility. So as I mentioned, these collisions have consequences for both people and wildlife. There's societal costs resulting in property damage, injuries, and even fatalities. But also there are ecological costs. So wildlife may be killed or injured. It fragments habitats and results in a decline of species. So in order to address this, a comprehensive approach that addresses both wildlife connectivity and human safety is necessary. There are mitigation strategies that are focused on drivers and attempting to change their behaviors, such as the Yosemite's Red Bear is a Dead Bear campaign. It's a public awareness program where they put out signage and try to lead or educate the public and enforce a safer habits. However, these are very temporary, and effectiveness goes down once people, keep driving the same road and don't see wildlife. They're like, oh, it's safe for me to go the same speed that I've been going. And then there are other mitigations such as wildlife-focused infrastructures, and these are underpasses like culverts and tunnels, or overpasses like wildlife bridges, and with fencing to guide the animals. So here are some examples of wildlife crossing structures. So underpasses, Caltrans conducted a comprehensive, they had long-term carcass data that helped them work in collaboration with other agencies to implement wildlife passes or culverts at Kuyper's Meadows and at Sage Hen Pass. This is an example of a culvert that allows larger species like deer and black bears to safely cross the highway. Another one that has been on national news is the Wallace-Annenberg Wildlife Crossing down in LA. This is going to be the largest wildlife crossing in the world. It spans over 10 lanes of the highway, of one of the busiest highways in the world. And the goal of that is to increase the gene flow of mountain lions. Successful mitigation projects are built on long-term data, targeted design, and multi-stakeholder collaboration. Inspired by these principles, the project focused on Highway 32, which is a corridor of conservation potential, but limited data. The following slides outline the methods and findings of the two-scale study designed to identify collision risk and habitat use along this corridor. So starting in our regional scale study, we begin at the Northern Sierra Nevada Foothills. It is a roughly 32 kilometers wide, 443 kilometer long ecoregion. It spans from Shasta County to Madera County. It is considered to be a crucial movement corridor that connects the lower elevations of Sacramento Valley to the higher elevations of Sierra Nevada mountains. It provides diverse habitat areas and food sources to over 600 species. And Highway 32 is one of the many roads that bisect this ecoregion. For the regional scale study, our area of interest is a 53-mile section of the highway, starting from the junction of Bruce Road up to the Highway 36 junction. So this map shows that Highway 32 and its impacts on the landscape. It bisects large landscape blocks. Landscape blocks are areas of land that provides habitat for wildlife and is generally considered to be protected. It includes lands from like national parks, national forests, ecological reserves, and conservation easements, I think. And as you can see, it bisects two major landscape blocks of the Chilkoot Wilderness Area and the Plumas and Tahoe National Forests more to the east. Furthermore, it bisects several wildlife linkages. Krause et al. In 2015 determined wildlife linkages, which are areas that promote wildlife movement and habitat for a number of wildlife species. And these linkages can allow for multiple, they can support multiple wildlife species. The lowest being 7 focal species that they utilized, and up to 26 species. The darker one is higher and higher species. So the regional scale study is a spatial analysis study to evaluate the spatial trends of wildlife vehicle collisions along the highway. The goal was to identify which habitat characteristics may be influencing the roadkill distribution. And the goal is to provide a broad scale context for wildlife mitigation. For the study, 177 roadkill occurrences were utilized. That was a dependent variable. These data points were collected by these agencies listed here from 1996 to 2023. And then the independent variables were the habitat characteristics. Some of the characteristics are like elevation, slope, land cover types, and intersections. And using those, I ran a ordinary least squares regression analysis to see how these characteristics are influencing the roadkill distribution. So here are the results from that analysis. Of all the variables that were tested, the 3 with the most significant of most significance was elevation, intersections, and herbaceous cover. Elevation had a negative association with roadkill, indicating that fewer incidents occurred at higher elevations. Percentage of herbaceous cover had a negative association, suggesting that fewer incidents occurred in areas with high herbaceous cover. Intersections had a strong positive association, suggesting that areas with more intersections experienced higher roadkill rates. But Rather than acting independently, the model indicated that it is the interaction of these variables that had the most significant impact. So areas that were at lower elevation with less herbaceous cover and more intersections had higher collision rates than other segments of the highway. And this model only explained 12% of the variation. Okay, so diving in, the regional model told us where these collisions are likely to occur and why, but to develop a truly effective mitigation, we need to know how wildlife utilize the space. And so this is where the local scale study comes in. So the local scale study was conducted on a 1.5 mile segment of Highway 32. This area is bordered by Beezer to the west and Little Chico Creek Canyon to the east. It begins at the southwestern terminus is at Crown Point Road, and the northeastern terminus is the Humboldt Highlands residential community. The local study utilized, or the purpose of the local study was to, the motivation for this local scale study was due to the shared interest amongst local landowners, Beezer and Caltrans, of increasing road safety and landscape connectivity. Furthermore, another motivation is that this study site, as you can see in this map here, the regional scale informed us that there is a relatively high rate of roadkill occurrences that occurred in this segment. So that informed us to continue to put game cameras for our local study. First, in order to find suitable locations for our cameras, we went out and identified areas of wildlife activity. So we went out there and looked for scat and carcass and wildlife trails to see areas of high activity. After we deployed 22 cameras throughout the site, during March to November of 2022. The detection period was from dusk to dawn, so from 1900 hours to 0700 hours. Data was retrieved approximately bi-weekly, and in order to efficiently organize the photos, I used a filing software called Renamer, and then I utilized Camera Suite to help analyze the images. So with the 22 cameras, for organization, these cameras were clustered. They were clustered based on proximity. There were 9 camera clusters in total across the study site. Here is the results of the usage of the study site by species. So during the study period, over 4,000 independent images were recorded. 15 individual species and 3 groupings of rodents, birds, and owls were identified. The 3 groupings were not identified down to species due to poor image quality. And one thing that is notable about this is that it is evident that gray foxes and jackrabbits reside in the study area, with gray foxes being detected over 50% of the time, and jackrabbits were seen foraging over 20% of the time. So now I'll discuss some of the notable observations in a few of the camera clusters. So first up is camera cluster H. It is denoted by the yellow arrow and the white box. So camera cluster H, the location of this cluster may help explain why roadkill occurrences were the highest. If you zoom in on the map, you'll see that there is 8 roadkill counts occurred right at the edge of this cluster. The location of this site, of this cluster, is that it's situated on a blind curve. It's somewhat sloped. They're going fast, and there's a restricted line of sight. And where wildlife is exiting onto the highway, that path is tucked behind a rock wall, which reduces driver visibility and animals from reacting to vehicles, but also I think it muffles vehicle noise for animals to react to. Here is the detections at camera cluster H. Once again, gray foxes and jackrabbits were most commonly seen. Overall, 9 individual species are detected here in 2 groupings. One notable observation is that animals are using the highway as their own travel corridor, suggested by this photo. And some of the cooler observations is that we detected a juvenile fisher after speaking with the biologist for Sierra Pacific Industries in the Sterling district. He thought that this is a female juvenile fisher, which then suggests that there might be a breeding area nearby. When he suggested that this individual may be about 6 to 7 months, which is right when they start dispersing and exploring their area. They're not fully dispersed, but they're exploring out of their dens. And other species that were detected were larger species like mountain lions and deer and black bears, which have been noted as the victims of roadkill in this area. On to camera cluster B, which is denoted by the gold box at the north end. Here are the detections. 11 individual species were detected in 3 groupings. Once again, gray foxes. It's much higher at this cluster. Oftentimes, there are multiple, often there were detections of multiple individuals traveling together, upwards of 3 or 4, kind of mobbing around in the meadow there. And this was also the only place that I saw a possum. It was the one detection that occurred. What we learned from this cluster is that the culvert that runs under the highway is an established wildlife corridor for medium-sized mammals. So species like ringtails, bobcats, skunks, and foxes were all utilizing this culvert to get across. Here's another example of bobcats. And on to camera cluster E, denoted by the green box. The detections here, we detected 11 individual species in 3 groupings. Again, gray foxes are everywhere. Gray squirrels are a little bit higher, and I believe that's because there are more trees at this cluster than in other places, so that provides more habitat for them. One of the coolest observations that I found at camera cluster E is the detection of two different mountain lions. One has a slender build and shorter body frame, and the other has a more robust build and a longer body frame. And also, there is evidence that large species are utilizing this particular cluster. This cluster is directly across from the Beaser entrance. And if you look at the blurry photo of the bear, you can see that the highway is right, mere feet away from the bear, and the bear is headed towards the highway. And you can see that the deer is, they travel from the highway and they're descending down into the Little Chico Creek Canyon. Okay, summary of results. So the regional scale study, based on the existing data, the combination of intersections, elevation, and low herbaceous cover best explains the roadkill, the distribution of roadkill on Highway 32. Though this is biased by sampling effort. The spatial model indicated elevated roadkill counts at the study site, though this may be attributed to greater sampling effort within the study site. At the local scale study, the camera trapping effort documented consistent use of a culvert by medium-sized mammals, indicating its role as a functional wildlife corridor, and fishers, mountain lions, and ringtails, which are all species of conservation concern, have been observed utilizing the highway and nearby right-of-ways for travel and habitat use. And large-bodied species, which are capable of causing significant harm to drivers, including black bears, deer, and mountain lion, have been documented within the study site. Project limitations. So at the regional scale, there was inconsistent reporting of roadkill data across agencies, thus lacking standardized protocol. The concentration of observations near Beaser and at lower elevations likely skewed the results, reflecting biases in reporting effort and site accessibility. The binning method that I used somehow affected how I could analyze seasonality and prevented me from being able to analyze the temporal effects. And due to limited data across the seasons, we couldn't fully evaluate how activity varied throughout the year. At the local scale, the study ran only for 9 months, which excluded the winter season, which is a critical period for deer and its predators. Also, the cameras only operate from dusk to dawn, which limited coverage of daytime activity. And technical issues such as camera malfunctions and theft created gaps in monitoring coverage. And sampling bias was introduced because we were only able to place cameras in accessible locations or where it was possible to place a camera without increased potential for theft. Here are my recommendations for future research and developing this project for more data, is to expand the monitoring not beyond the study site to the entire highway corridor, and to run it for year-round 24/7 camera deployment. Utilize software such as AI-assisted image processing or file organization, and to upgrade the crossings that have been identified by retrofitting them, and to assess for other locations for potential upgrades. And to improve the collection of carcass data, it would be great to standardize reporting across agencies. And I also think it would be cool to partner with UC Davis and the Road Ecology Center and utilize their observation system, which is a web browser-based software that folks can just upload their photos with their GPS coordinates to help them identify the roadkill that they see. And this will help us refine the collision hotspot model. And lastly is to increase stakeholder coordination across agencies like Caltrans, BSER, PG&E, CAL FIRE, so that their work doesn't impede on research and monitoring efforts, and some sort of a protocol to formalize communication. And so this map on this slide here indicates the red stars are the key spots that I discussed with notable observations, and the blue stars are locations that have been identified based from the field trip that we took with Caltrans District 3 with Ken and Greg. I think it would be potential locations to set up cameras in the future. And I like to acknowledge Elizabeth and Hollis for having this idea and bringing this project forward. I know that she was very a strong advocate for wildlife conservation and all the projects that BSER has that's wildlife related. And I want to thank Ken and Greg for their support and their knowledge. Colleen and Kristen, thank you for your time and patience for reviewing my paper a bunch of times. Eli for bringing this project forward and finding the funding. Local community and local landowners that funded this. I really appreciate it, and it wouldn't have happened otherwise. And I want to thank Michelle Clark of District 2 for providing their carcass data. Fraser Schilling at UC Davis that provided his data collection. I also want to thank Sarah, who's on the chat, I think, today, for coming out on our field trip and giving us insight about how DFW plays a role in all of this. And I want to thank Susan and Joanna for hosting the writing sessions after hours that kind of pushed me to keep writing. And I want to thank Gary for creating the program and just all the background support, technical support, and setting up everything for all of us. And with that, I finish my presentation and open the room for questions.
All right.
So can someone monitor questions if you have questions if you're on the teams, if you have questions, can you put them in the chat? Can someone monitor those?
I'll watch it right here.
Questions?
Okay, I'm ready. Yes.
I'm curious on the culvert that we saw, ring-tailed cats, bobcats, and this might be a recommendation for a future study too, but with any larger mammals like looking at that wildlife crossing, but then deciding to go further down to where they were accessing because that was not accessible and there was the...
I do have detections of black bears that kind of peeked in the culvert to see what was going on, but it was clearly too big to go through and it would have gone stuck. And then just moved on uphill. I'm not sure where it attempted to cross. That location is particularly difficult for wildlife to cross because of the steep embankments that are on either side. It's possible that it turned back and crossed on the eastbound side. There's a natural at-grade location that kind of funnels wildlife to cross there. There has been a detection of a full, a complete crossing of a black bear at the funnel that's just south of the culvert.
Yeah, and I would just note that right next to that culvert, a black bear was fatally hit last week. Actually by a faculty member, totaled their car.
Oh my gosh.
yeah, wasn't related to beast or something else, but it, that had jumped the railings there.
Oh, wow.
Yeah, that was just last Thursday.
That's so sad. Questions? Questions?
I got questions.
Go Dawn.
Go down.
Should I get started?
Yeah.
I guess I was bracing myself for, you said it's a 27-year span. I was bracing myself for thousands. Is that, am I the only one? No. And then you said 177.
It's not very much.
Well, it's too much, but you know, it's fewer than I thought.
Yeah, so at the Sage Hen Pass and the Khyvers, Highway 89,
Wow.
on the other hand, has long-term data which spanned, I think, about over 40 years of
Wow.
consistent data, because that is a migratory corridor for the Loyalton deer herd, which is not as big as the East Tehama, I don't think, but it's still a significant size deer herd. So that was one of the reasons that they were able to put culverts in with, you know, not taking years and years and years.
I imagine they're terribly expensive, and that thing in Santa Monica, isn't that millions and millions of
Yeah.
long lines?
The Wallace Annenberg one is roughly $92 million with advanced engineering. The one down in culverts, modified culverts, are generally in the 6 to 7 million range.
Wow.
It really depends. It's very site specific, and the engineering effort that is required there. Yes.
In talking with Caltrans and looking at this data, is there a specific site that from an engineering perspective and from a data perspective that you would recommend for enhancement?
I would recommend the culvert. From speaking to Ken and Greg, they do have a standardized protocol for modifying an area with a known culvert, like making it larger. And it seems like it's something that they have made it efficient. So they would like close down one side of the highway, put in one section, close down the other side of the highway, put in the other section, and puzzle it together. It's a relatively easy effort for them. Other locations, I would suggest with that culvert, we would need to put fencing, particularly where the bear was hit, because it's an at-grade location. You would want to put fencing so that the animals can be funneled to the culvert. Basically, animals need to be trained to utilize these areas. Yeah.
There's a question in the chat that feeds off of that.
Okay.
Are there more like formal plans or anything based off those recommendations to get this all in motion?
So this project, as far as I know, is the only one in this region or in this area that is on Caltrans radar. And it is a priority location. It currently lacks funding. So let people know that this could happen with money. Yeah, it's on their radar. It is in one of the most recent reports that they published in 2024. Yeah.
I have a question.
Yes.
So it's two questions, I guess. So I'm curious, so the carcass data, the 177 carcasses, do they kind of follow what you found with the observations of like what's crossing the road? Like did it have a lot of gray fox and rabbits as the majority, or?
No, it was mostly large mammals. It was predominantly deer.
Yeah.
But these carcasses are collected opportunistically or when someone calls it in and asks Caltrans to pick it up.
Oh.
So sometimes it's unknown what it was. Sometimes, you know, like for example, there was a couple data points that were on black bears in the upper parts of the Tehama side. And they were all located in like one location, but we don't know enough information. Like, was it a family? Like, was it adults? Was it juveniles? We don't know that data. It was just that we have a GPS point and where it was collected.
So there's a little bit of skew in the data,
Yeah,
that
yeah,
like,
sure.
if you hit a deer, you're probably calling somebody,
Yeah.
but if you hit a fox,
Yeah, you're just gonna keep driving.
Yeah. And so then it kind of builds on your ordinary least squares model
Mhm.
had kind of low,
Variation,
correlation
yeah,
there to explain the model.
Right.
What other variables do you think, if you could have anything that you could put into that model, any other data, what do you think might help improve that?
I think looking at seasonality, and looking at like the speed, maybe the time of day, because especially with Highway 32 being a east to or west to east based travel route, drivers are affected by sun glares, and the shadowing of the trees. Looking at that, maybe looking at pre and post of like say a vegetation removal, how that could impact a section. I think those are the couple that I could think of top of my head.
And more data.
And more data. I would love more data.
That's great. Thanks.
So another question, so the culvert that you're thinking would be good to improve, it sort of is in a meadow that butts up against that housing development. Do you think that the residents would be amenable to you using fencing that'll sort of direct more large mammals towards their backyard?
I like to think that in general that the people that live in that corridor and in the canyon are proponents of wildlife and appreciate nature. I think that it is important to bring them to the table to discuss safety concerns and how we can ensure that the wildlife is able to move safely, but also that people and their kids and their pets are also safe as well.
Knowing that most of your camera data was during the day, do you, based on the species that were present, do you think that those abundances would change with the 24-hour camera captures? Knowing that some of those animals are probably more likely active in the dusk and pre-dawn.
I think it would change it. I think we would have greater detections, obviously, if we did it 24 hours. One of the interesting things that I found is that with bobcats, they're known to be crepuscular and nocturnal. However, it seems that there was a switch where they kind of just disappeared once the high summer temperatures came about. And after about July, they weren't detected at all in my study. And this also kind of corresponds to Karina's study, where she also noted that there was a shift in their activity. So, I missed that obviously without the daytime activity. I think it's important, obviously bears are crossing during the day. I think that as we go closer to communities, animals are adapting their behaviors, and some species may be operating at night, and it could also be the opposite, where they're operating where there's maybe less traffic. So outside of the high traffic times of where commuters are going home and going to work, maybe they're adjusting to that. So without the daytime activity, they can't really say what's happening.
Question in the chat that kind of piggybacks off that too. It says, if you were to do a subsequent study that builds on the results of this one, what would that study entail? So you're already kind of touching on some of that.
Yeah, I would like to go beyond the right-of-way and go further, and that will help with reducing false detections of vegetation in vehicles, and that will allow for daytime monitoring. Because that was the biggest thing, is that there was a lot of vegetation triggers. I was having thousands and thousands of useless imagery running at 24 hours. And so I would expand it and go further away from the highway, I would also do the entire corridor, and I would collaborate and utilize data from other agencies that are already collecting it for their reporting. So like Forest Service with their wildlife team, or Caltrans and their data, just collaborating and gathering as much data as possible.
It's nice about having it a little further from the highway. You can also seek those like possible crossings that then they approach the highway and then they leave and decide not to cross it, but they would have crossed it if there was a safe corridor.
Building on that, I have another question to Chad. What other data beyond camera traffic and roadkill do you think would supplement your study, and how do you think that would affect your results?
In terms of the overall results in informing us of where there's activity, and I think Caltrans utilizes this, where they gather information from other agencies, and if those species occur within their large-scale study area, then there are also potential victims of collisions, right? And that could inform us of like, hey, like we need to look out for these species. And maybe they're, looking at data, we can see clusterings, and then we could go there and look more in detail, like specific wildlife trails that are heavily utilized, or resources such as a creek or some water source or some food source that's heavily utilized that could be leading animals to that area for further monitoring.
One of the things you haven't mentioned is the collaboration with SBI. Do you think that would be useful?
I think so. They have done research with other universities. They did a fisher reintroduction, specifically in our area, the Big Chico Creek Canyon and Little Chico Creek Canyon. And so being able to talk to Matt was like a wealth of knowledge of what happens on private land, and they should definitely be at the table with talking and to collaborate with, because they are in charge of so much land of habitats.
We saw a Pacific fisher on Friday across on the east side of Big Chico Creek.
Oh, cool.
They run along the creek.
Oh, that's cool. How big was it? Adult?
It looked like it was a juvenile of some sort. It was like this big, but we were reintroducing native fish and saw it run by at the same time. It was kind of rad.
That's awesome.
Any more questions? Anything to chat, Gary? Go done.
Sounds like these are chiefly mammals that you've been observing and concerned. I was wondering, now I know that there's supposedly this East Tehama deer herd, common black-tailed deer, and they're supposed to be migratory. Are there other mammals actually migratory seasonally so, besides the deer?
Not within our study, but I do believe that mountain lions are probably moving with the deer as they go to their summer ranges in the higher elevations, and when they come down to the lower elevations in the fall and the winter time. So they would both be impacted. Yeah.
So to speak.
I guess I have more of a comment, I guess, but like Allison's project, I don't know a whole lot about it, but on the potential for reintroducing to elk, I mean, this project seems really important for that if we're gonna have another large.
One important point that Allison has told me is that based on the studies that she has found, which there aren't that many with Thule elk, is that they can range up to like 15 miles a day. And so even if we reintroduce them in like the expansion side, they could easily get to Highway 32. And so they would be a collision risk in the future. So maybe we'll likely need a wildlife bridge, because elk do not like to go through small spaces. They like open areas. So we would need to consider a wildlife bridge.
Start fundraising.
Yeah.
Okay.
Just 50 million.
We'll get the philanthropist from down in LA to help out.
Yeah.
Yes.
So this is not in the context of your study per se, because it is important in its own right. In a highly competitive environment, how unique is the opportunity along 32 based on, all the various features?
So the way I attempted to look in terms of my writing and how I try to find the justification to kind of push Highway 30 to the top is that we have these 3 species of concern, the ringtails, the mountain lions, and the ringtails and fishers. And ringtails are so elusive, they are hardly studied. There's maybe a handful of studies up in this region, in the northwestern end of their range, and their habitat ranges from, the Cascades down to southwestern, like New Mexico and Arizona. So it varies, and there's just not enough information. And so I think it's necessary to protect, and they are fully protected under California, mostly because they are so elusive and we lack the information. Fishers, the population that is up here is one of 2 subpopulations. They're distinctly different from the species down in Yosemite area. So I think it's important to protect them. And mountain lions up here, while they are more genetically diverse compared to the southern populations, this population up here could help restore gene flow over time. And so it's necessary to proactively protect the species up here to help eventually with the species down south, potentially. And sorry, I don't know.
What was the third species?
So we had mountain
fishers.
lions, fishers, and ringtails.
Ringtails, yeah. So, just a suggestion. We should invite the California director of the National Wildlife Federation up here.
Okay.
Beth Pratt is as relentless about this issue as Eli is about fire. And she's connected to the Yosemite Fisher collection. She was a driving force. P-22 is the biggie, but still a driving force. And she appreciates that sort of valley to upland. And she also appreciates the significance of the big federal lands, whether they're, but particularly national parks because of her background. And it's not lost on me, there are 3 corridor travelers through there. They're the regulars, they're the forest regulars, and they're the one-time backdoor to Lassen. And we invite her up, she'd come.
We would love to have her here.
Go and call her.
Okay.
Yes.
I mean,
Yes.
that strikes me as getting it on her radar screen will help if this is real, if there's something really there to play with. But she's all about FICA, and that's up at the volcanic end of things. And she cares about mountain lions, pretty obviously, and this is her state.
Yeah. And another point to the justification is that a lot of these wildlife studies are mostly done on high trafficked recreation corridors like Highway 50 or 80 that go to these big recreational destinations. But Highway 32 is also a travel corridor for recreation destinations like Lake Almanor and the Volcanic Park. And so we have this ability, and the fact that we're doing all this forest health management of the area, and there's big chunks of land that are still unfragmented and protected, that we can be proactive in conservation of Highway 32 before all the cars get here.
And just one last, just so that I kind of better understand. That we have demonstration gardens all over everywhere. It strikes me as the terrain and the relative access to destinations and urban amenities. This would be a really
perhaps a really good corridor to demonstrate systematically lots of different types and scales, because we've got the anchor institution, we've got the relationship with Davis, again in the park, and Beecher here. It could be, just sort of from a unique positioning point of view, if Caltrans were celebrated for making systematic investments that could be adopted other places, those two things, it seems to me that's kind of a unique positioning angle for that piece of road.
I agree. I don't know how to get that going, but love to be part of
You
it.
just did.
Yeah.
Your study.
This is part of it.
Yeah, I mean, that is sort of my last question is this your master's thesis or is this the beginning of your life work?
Yeah.
I would love for it to be the beginning of my life work.
Good to know.
There is a question in the chat.
Yes.
That builds off of the animals you were talking about.
Yes.
So it all kind of relates. And I think you kind of touched on it for sure. So which group of animals do you believe are the most vulnerable to the negative effects of the highway within your study area? Like abundance, sensitivity, special status, which I know you kind of covered, but also the fire effects. Those are all on this connectivity area.
So in terms of the species that were detected in my study, I think the most vulnerable are the ones that aren't fast moving. So like deer are relatively fast in like getting across the highway. But you know, species like a possum is probably not fast enough to cross the highway, even a 2-lane smaller highway. But also we have species that would just avoid the highway, and that causes a complete barrier to movement, and that, you know, affects them long term as a species as a whole. In terms of fire, I'm not as well versed, but I would imagine that, you know, as things continue to like grow at Beecher, there's going to attract more species with forage and browse materials. But I also think that it's have a negative impact to species like fishers that require an older growth type forest that needs the heterogeneity of structure and dens that is, you know, somewhat gone now, where in the areas that have burned. So, was I able to answer the question?
Yeah, good.
Okay.
I mean, I can say that from that now, you know, whatever it is, 9 months past the fire, 8 months past the fire, we're seeing like more browse per acre, of course, right? There's significant growth and browse material. We're seeing on our traps lots of deer, bear back. The Pacific fish has been sighted 3 times since the fire, or multiple fishers. We're not sure. We haven't been able to catch an image of it each time. And there actually is really good fisher habitat now, because a lot of the hardwood trees, even the ones that burned up, have really, like, I mean, I saw 3.5 foot diameter tree that was completely hollow the other day.
So there's more dens now. Okay.
There's a lot more dens, for sure. And so, yeah, and then our management goals are going to be, you know, taking this as an opportunity. But I foresee this fire as even after year 1, maybe, but down the road, year 3, 4, 5, and as we move forward, it's going to create significantly more habitat for all the species that we're discussing today.
That'd be so cool to see. Yeah.
Any more questions?
How fun was this? You get to look at animals all the time.
Is it as fun as going out and doing a survey? No. But it's really cool when I get a photo and I'm clicking through it, I'm like, a fisher! And like, as soon as I saw a fisher, I was like, I gotta email everybody. So that was really cool. I learned a lot about the art of game cameras. They're much harder than I figured. And that had a huge impact on my data. So if I were to do it again, knowing what I know, I think I'd be better at placement. Yeah.
All right, well, if there are any more questions, the committee will stay and really drilled her hard. And really thank all of you guys, everyone on Teams, appreciate you joining us. And
Thank you.
let's give it up for.
Thanks, Ellen.